Alright, so check your answers on the homework. Make sure you're doing it right. If you have any questions, okay, circle them or something so that when I come back we can go over them. So all I had to do was label independent, dependent. So x is independent, f of x is dependent. Okay, the number of loads of laundry you do affects the cost, how much money you're spending, or the balance remaining on your card. Okay, so domain and range. Domain can only be those specific p's. Range can only be the y values. Okay, the initial amount of the loan is when you've made no payments. So when p is 0, the loan is still 120, or the balance is 120. Okay, down here, this should say the balance as a function of the payments is equal to 120 minus 30p. Just like the one we did yesterday, except this was 270 instead, I think. Okay, so you had to fill in a table. So he has $40 and he puts 20 away. So his balance as a function of his deposits is going to be whatever he started with plus his payments or his deposits. So it's $20 per deposit. So it's 0 deposits, he's 40. At 1 deposit, you plug 1 in for D, you get $60, $80, okay? All the way down. You plug it into coordinates. Here's your x's. Here's your y's. So from that, you make your graph. The number of deposits is our independent variable. We change that. The balance depends on how many deposits we make. So we start at 40, we go up by 20 every time. And over here, if we start with 70 instead of 40, it would just shift up a little bit. It would shift up by 30. So we'd have 70, and then plus 20, plus 20, plus 20, plus 20. So we'd have 90, 110, 130, blah, blah, blah. Okay? Your domain is your x's, or how many deposits you do. You can't make half deposits, so it's only these specific points. And your range goes from your starting all the way up to however much you want to end with. Okay. 14 was asking you to predict when you would have 220. So all you do is you have your equation. Remember b, what is it, b of d equals 40 plus 20 times d. If we want 220, 220 equals 40 plus 20d. Solve for d. You end up with 9 months. If you made 15 deposits, you'd have $340. Okay, this over here, the balance when there are 22 deposits equals $480. So after 22 months, you'd have $480. That's pretty good. Almost 2 years, you save $400. It's better than saving no money. Okay, this is just review. X values, Y values, any of these overlap. 1, 5, oh, we got 5 over here. We have some duplicate X's, so it's not a function. You look over there. Okay, this one is just decimals, but it's still the same thing. There's no duplicate X's, so it is a function. Okay, come down to this one. All the X's are only going, there's only one X going to each thing. There's not like one going here and one going here. If this were the case, you would have duplicate X's, and that would not be a function. But since it's not doing that, it is a function. Remember, domain is X, range is Y. Okay, day 3. We're talking about discrete and continuous functions. Sounds kind of weird, but it's not too different than what we've been doing. Okay, so a discrete function, that's where the x's can only be specific values on the interval. They can only be specific values. So think of something like that. Okay, it can only be these specific points. You have a continuous function, that's where x can be any value in the interval. So think of it like something like this, where the points are all connected. Okay? Discrete, not connected, continuous, connected. Okay? Think of it like that. Continuous, connected. Okay? Continuous functions are connected. Discrete functions, not so much. Okay, continuous functions are connected. Discrete functions are just specific values. Okay, so we just have to label or determine whether or not these are continuous or discrete. Connected, yes or no? No. This is discrete. Connected, yes or no? Yeah, so this is continuous. Connected, yes or no? No. This is discrete. Okay, number 4 is a word problem. This function represents the number of people. Okay? So what these continuous functions mean is that you can have 0, 0.1, 0.2, 0.3, all the way. You can do 0.01, 0.00, okay? Every number in here works. Can you have half a person show up at a banquet? Or 0.25 people? No. You can only have whole number of people. So it's going to be something like this. So this kind of graph will give, or this function will give you this kind of graph, where it's just points. Nothing in between. So that would make this a discrete function. There we go here. Represents the number of hours worked at your job. Okay? Generally, you can't work 0.3 hours. Okay, you're only given credit for hours, maybe half hours. Okay? But you can't have 0.25 hours or 0.1 hours. So this is also going to give you something like this. And we know that this is a discrete function. Okay, if your dependent or your input or your independent variable can only be integer numbers, then you know it's going to be discrete, because it'll give you something like this. If your input, your x or whatever, can be anything, then it's a continuous function. Okay, we buy a printer for $80, then pay $15 for each ink cartridge. Function relating the cost in dollars is right here. So N is the number of ink cartridges. Want you guys to fill this out. A couple minutes in your groups, work together. All right, so let's go over this. We have our number of ink cartridges. We have to plug in right there. So what is 15 times 0 plus 80? That gives you 80. 15 times 1 plus 80, so 15 plus 80 gives you 95. 15 times 2, which is 30, plus 80 gives you 110. 15 times 3, 45 plus 80 gives you 125, and then finally we get 140. So this is coordinate notation, and in coordinate notation you just put it in coordinates. So you take your n, 0, and your cn, which is 80. So you have 1, 95, 2 and 110, 3, 125, and finally 4, 140. So on our graph, we have to label our axes. So our x-axis, our independent variable, is the number of ink cartridges. Okay, we can change how many we buy. And what depends on that is the cost in money. Now this is going to be n, number of cartridges, and cn. So let's find some intervals that work. So our number of cartridges goes up by 1 every time, so we can do 0, 1, 2, 3, 4, 5, 6, okay, all the way. And over here we go from 80 to 140, so we could do maybe 80, 90, 100, 110, 120, 130, 140. I like that. 80, 90, 120, 30, 140. So at 0 cartridges, we have $80. At 1 cartridge, we have $95, so that goes right there. 2 cartridges, we have 110. 3 is going to be at 125. 4 gives you 140. If you have different intervals here, your graph's going to look a little different. But the important thing is that you cannot connect these in here. You can't buy half of an ink cartridge. It has to just be integer numbers. So what kind of function is this? Discrete or continuous? Okay. Are they connected? No. So it is not continuous. It's discrete. Let's find the domain. Remember, that's your x's. Your x's can go from 0, 1, 2, 3, 4. Now range, remember, it's our y's, can go from 80 all the way up to 140. 80, 95, 110, 125, 140. Okay. Is it a function? Are there duplicate x's? No. So yes, it is a function. Our independent variable, that's going to be n, our number of ink cartridges. Our dependent variable, that's going to be C of n, or the cost. Okay, you can do cost and number of ink cartridges, that's fine. Okay, the initial cost, that's going to be $80, and there you go. Because because you don't buy any ink cartridges yet. If yours doesn't come with ink, then you got to buy one, so your initial would be 95. Okay, hopefully, since we've been doing a lot of these, you're able to do this in your groups. If not, okay, we need to go over this when I come back. Okay, which variable changed if the price of ink cartridges increased by $5? So remember our equation was cost, oopsie. The cost, which is a function of the number of ink cartridges, is 15 times n plus 80. Okay? Which variable would change? So our new equation would look like, cost as a function of n, would be 20n plus 80. Okay, if we had, the printer was $90, our function would be, the cost as a function of the number of cartridges, would be 15n plus 90. Okay, hopefully you see why things change when they do. So we kind of already talked about this. Why is it discrete? It's because nothing's connected. You can't have half of an ink cartridge or 0.3 ink cartridges. You can't buy those. You can just buy whole number integer ink cartridges. Nothing's connected. Okay? So you guys, in your groups, try number 12. So it's making the equation, graphing it, all that stuff. So you guys, in your groups, try this for a couple minutes. Alright, so hopefully you guys were able to get the equation, graph it, do all that stuff. So, Andre receives $40 gift card. It costs $2 per song. Write an equation to represent this. So, the balance, okay, to represent our downloads, we'll use D. Now, how much money is it per download? $2. And we know that we started with 40, and every time we download a song, it's going to take money away from that. Okay, so our function, the G as a function of, I know it says S, but I use D, is equal to 40 minus 2D. Okay, hopefully you guys were able to write this function. So we go through. This is our download, so you can have 0 downloads, 1 download, 2, 3, 4. And our equation. All I did, I put instead of S, or instead of D, I put S just so there's less confusion here. Okay, so all we do is we take our S's and we plug them in here. So if you don't download songs, you still have $40. If you download one song, you're going to have 40 minus 2, which is 38. Download another song. This is 4, so you get 36. 34, 32, okay, keeps going down. You just plug your S's or your X's into your equation, into your function. And over here in coordinate notation, we have our X's, which is 0 for this case, 0, 40, 138, 236, 334, and 432. Okay, those are our coordinates. For your graph, your independent variable, that's going to be the number of songs. You can change how many songs you download. And your dependent variable, your gift card balance, that depends on how many songs you download. So it balances in money. We know that this is S, this is G of S. Our downloads, so our number of songs, let's find an appropriate interval. They go by 1, so this would be 0, 2, 3, 4, 6, blah, 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 all the way. And our Y's go from 40 down to 32, or even lower. So we could have 10, 20, 30, nope, can't do that. We could do 15, 30, 45. Okay? So every 2 is 15. You could do that. So we got 30 here, 45 there. You just have to find an interval that works. So if you wanted to go 10, 20, 30, 40, you could do that. That'd be fine. If you want to go by 4s, you'd have to stretch it out. Just whatever works. And we could say, if we want to be really zoomed in, we could put 40 right here and maybe 32 down here. So 40, 38, 36, 34, 32. That's even better. So there's 30, 32. Okay. This would be really zoomed in. So you'd have to do a little break in your graph there, but don't worry about that. Okay, you zoom in. 0 downloads, 40. 1, 2, do, do, do. Okay, we keep going down. So, is this discrete or continuous? Are these connected? Can you have 1/2 songs downloaded? No, they're not connected, so it's discrete. Your domain is your x values, which can go from 0, 1, 2, 3, 4. Okay, it could go on until you ran out of money. Your range is your y value, so we're going from 32 all the way to 40. 32, 34, 36, 38, 40. Okay, our dependent variable we know is the balance, or G of S. And our independent is the number of songs. So you could have written balance, number of songs. That would have worked. Is it a function? Are there any duplicate x's? No. So it is a function. Hopefully you guys are able to make these graphs, tables, determine all this stuff. Okay, initial cost. So remember, our function is g of s, 40 minus 2s. The initial cost value, so that's not downloading any songs, that would be $40. Okay. Is it possible to have negative money on your gift card? No, because once you get to 0, that's it. They're not going to give you more money to use. Okay? Once this is over, once you get to 0, you're done. Okay, the limit of our domain. Okay, we can have 0 downloads all the way to 20 downloads, or 20 songs. For the range, we can have 0 all the way to 40. Okay, we stop at 0. Since this is a gift card, you can't have any negative money on it. So for your homework, looking at graphs, seeing if they are discrete or continuous. Remember, connected, continuous. Looking at some word problems. Are they continuous or discrete? Word problems. Underline the important information. Okay? X pounds of beef. Price for beef was $1.49 for the first pound. And $1.09 for each additional pound. So write an equation that shows that. Number 7. Oh, this sounds familiar. Starts off with $40. He saves $20 every month. So what does this equation look like? Down on 8. Movie theater charges $8.50 for an adult. Okay? Theater management agreed to reduce the price of each adult, so they're going to reduce it by 50 cents for every can of pet food. Which of the following shows an equation that represents, okay, if they contribute cans to the animal shelter? Okay, so make sure you underline the important information here. So the highest price you can have is $8.50, then it goes down. The cost of a wedding is $150 plus $17 per person. Write an equation, fill in the graph, table, all this stuff. You should be able to do this. Okay, we have a $40 gift card, $8 per visit. This is what the function looks like. Go through, graph it, label it, find out this stuff. Now you determine whether or not these are functions. Remember, vertical line test, duplicate x's. Vertical line tests, are there multiple points? Okay? That is it. So, I will be back on Tuesday. If you have any questions, make sure you write them down. We can go over them on Tuesday when we kind of review all this stuff. Okay? Make sure you do your homework. Okay? Functions are super important. So we'll spend a lot of time on them.